My name is Basanth. I'm the chief architect at iVoyant. We are a solutions company. We build custom solutions for a lot of clients. So wanted to talk about this topic, CDC replication to Redis, which is like change data capture replication to Redis from Oracle, MySQL, and other data sources like your typical legacy systems. So let me start with what we will go is, we'll go through these like things, the typical challenges that most of us face, like sourcing data from in an enterprise, because most of the data is siloed in organizations that have existed for years. The new age companies are a little different, but I think most of us work with a lot of companies that have been there for years and years, and they've accumulated data for a long time. And then so we will see how we can use change data capture to source the data from these legacy systems. And we will talk like a little bit about the connector for Redis, and then a quick demo, all right? So, and I'm sure like many of us here developers would have faced with this, hey, I want to build a new service, but I can't get the data because where the data is, it's a system that is like too important for the company. You can't query this data. You can't get the data from there. ETL is like little too late, So we all run into that issues. So you can't touch that system and stuff, right? Or the other thing is, hey, my DB is overloaded. It's too expensive to expand it. Too expensive to scale it. So let's forget about this for now. So we all know that we do advocate like new use cases, but sometimes I think the cost of doing the solution is like too expensive because sourcing data is a pretty complicated problem there, right? So also we do see sometimes that, hey, I want to do add this new feature, but you go to the system of record, and it's usually takes a lot of time because it means that you have to change a lot of existing systems and those kind of things. So either we can see we can either do it or we can just just leave it as is, right? So a lot of reasons, a lot of questions, and that I think sometimes because of the problem in sourcing data, a lot of new features that we can introduce to the client or customers basically ends up getting dropped. So these are the typical roadblocks that we have seen in building your modern applications. I think let's suppose you want to build a microservice wherein I think you want the data to be closer to the service, but there are challenges that we face there. I think it's either because the databases, they're legacy databases. And then sometimes we do have systems that are fragile. I think so. If you run a query, you write to do too many transactions than what the system is designed for, it might end up in messing up your system of the system that actually a transactional system in your company. Right. The bigger reasons for most of them is I think difficult to scale those systems. I think your typical databases are hard to scale. Especially scale it horizontally, right? So to address this, I think we have all these new age databases like Redis, where you can scale it horizontally, and you can get the performance that you need at a pretty low cost. But but I think so how do we get the data to those kind of those systems, right? So that is the thing that we're going to talk about here. So. So I think some of you might have used CDC. I think mostly people from the database world would be using CDC to replicate data from one database to another database. And there are quite a few products, commercial products out there. I think you have Oracle Golden Gate. There is Streams, IBM as a product. So there are many companies that have Unity is there, and so there are a lot of companies that do change data capture products, but they're pretty expensive, and also. The connectors from one, you might not have a connector for the one, or you might not have a solution to actually write it the way to the target system the way you want. So what does change data capture do? It is it propagates the copy of the primary database without disrupting the ongoing process. So this is a pretty lightweight process compared to us querying or polling the database and stuff. This is like the most elegant way to get the data out of the database. Like, so also like what CDC does is it actually like you can propagate the changes as they happen, in the sense, you can do an insert, you will see an insert being played, you see a delete, you will get the delete being played. So it's in the order in which the transactions happens on the database system. That is the way the changes could be like, replicated. So also like, you could like filter out the changes that you want. You don't necessarily need to replicate the whole database. You can replicate a table, you can replicate like, replicate the things that you need. So couple these like, changes that, use a technology like CDC and then couple this up with Redis, you can democratize your data then. I think, once the data is democratized, then I think you can like build pretty neat solutions on top of it. So obviously there are this is something I think if pursued, I think you have pretty good like business benefits for this and as well as technical benefits, right? So business benefits wise are like, from the bottom line perspective, you would not be spending as much money and resources to like build a solution like this. Instead of like, scaling your like database and things, I think this is, and also you would get like the solution like faster to, quick to market, because I think you might be able to build the systems much faster than actually going against a traditional system. So this also enables you to like, think of solutions that you might not have thought of before because of the non-availability of data, right? So this is the typical like, business and technical benefits. We'll go to the next one. So what are the typical goals for change data capture, right? I think you can build value-added microservices. You can once you like, once you like start like getting the data from the legacy systems, which could be like, a number of those, it'll help you to like, build value-added service on top of it. You can do like, machine learning, AI, any of those kind of cool new things. And also like you get the changes in real time instead of like waiting for like hours or days or like, or batching, you get them pretty much in real time. And also this helps you to consolidate various different databases into a single one. And especially a multi-model database like Redis, it is even better because you could actually build like more compelling use cases on top of it. So we'll just go here and see this, right? I think the eye level, what we have is we have actually built a connector that will source the data from a lot of these various databases that we all are aware of, like Oracle, MySQL, Mongo, various things, and then move it to Redis like without having any intermediate messaging or any of those things in between. So this connector is just a piece of software. Like, if you were to use like Oracle, it would be like Golden Gate, and then there are other like products available out there which enable you to get the data from other databases. But I think in this demo and today's like talk, we are going to be I will demo it with Oracle Golden Gate. So what the Golden Gate is basically a piece of software that actually sits. Let me go to this one. This might be a better one to show. Right. So this is a typical way the most of the CDC works. So I think you have a database. All the database, as the changes happen, they are written to redo logs. Redo logs are like where every change that happens on any table is basically written over there. Then you have a process called as extract, which reads this redo logs and then creates these files called as trail files. Right. So the trail files basically contains a series of changes that has happened in the database at any point of time. So if you executed a transaction, the transaction contained like 4 different statements that are executed. Those 4 would be like captured over there. So when the trail file then gets shipped over to whichever destination that you want, so from this point of from this point, we don't really care like where the database was. All we care about is the trail file. So once the trail file is there, so you can have a user exit, which is like in our case it's written in Java. So this user exit then takes it and puts it into Redis, right? So you have then you use all the cool features of Redis, like can batch the statements, just for performance and all that stuff. All that thing that a connector takes care of it, right? So this is at a very high level what the architecture for CDC is. I think you. So the trail files also could be like shipped. So if you are in an organization where already the CDC is there to replicate data from one database to another database, you can always take those trail files, ask those trail files to be shipped to a different location, and you can use that. You can write a connector off of the trail files and get the data replicated to Redis. So you don't necessarily need to create a new set of trail files, right? So a lot of organizations have that, especially the organizations that have are pretty database centric, have solutions that are database centric. I think have this technologies already in place. So let me go back to the slides that we had. So this is like the architecture for our connector. So what we have done is, I think we have put it in a Docker image, so that the idea of this is to isolate the developers from not learning like newer technologies, but just use like things that are very familiar to them, like using a XML configuration based approach. So you configure which tables you want, you configure which columns you want, and you tell like I want to filter this, filter that, lightweight transformations, and you would be able to like see the data in Redis, right? So what are the features of this connector? The features that we have implemented here are like lightweight transformation and artificial keys. In the sense, if you go in a database, you might have your primary key as something, but you could change in our connector saying that I want this particular column to be the key. You could specify that, and I think the connector code takes care of stuff like that. So also move the data from one source to more than one Redis instance if needed. In the sense, there are sometimes you might be getting data from a particular system. You want it to go to your like development and QA instance, for example, right? You could do that. Like you can do more than one sync. So from a given one source, you can write it to more than one sync. And we can tell whether you want an async write or a sync write, depending on your needs. You would like obviously asynchronous writes, you get like better performance, but you would say like those things of configuration you can do. And also like synthetic key, delete records on synthetic key changes. In the sense, let's suppose you have a key that the key could be changed, right? In the database, when the key changes, I think you can tell whether you want to delete the record in Redis, or you want to just keep it and then create a new record in Redis, right? So those kind of changes we can do. And also you could tell which columns you want to choose, which columns like and do you want to publish the columns only on changes and things of that nature, right? So for this, like most of us developers, I think, would have seen the HR schema in Oracle. So I'm just going to like take that one to do the demo. Here are like two typical configurations that just for this demo purpose, I've created like two of those. The first one, what it says is, I think let's go through these properties here, right? So this one, the processor ID basically identifies the implementation on our side, and when it says pass through true, it means that it's not really doing any other additional logic. It means that all the columns from the source are pretty much copied to the target. And this is target in the sense here like Redis. And then we have said like delete on key update is true. It means that if I go and update a key, then I think I want the record that was changed to be deleted and a new record to be created. All right. So and you see here like Redis sync, we say that like we would give a connection ID. We have a connection properties file wherein I think the Redis related like connection properties are stored, and then we are telling we want it to be of type hash, and then asynchronous is true in this case. All right. That is the first processor, and the second one, if I see here, it's the same table, but what we are doing is we are like making the keys like different here, like now employee underscore array as employee number and what type it is and all those kind of things, right? Instead of replicating all the columns. So in the first case, what I would see is if there are like 50 columns there are going to be 50. In the hash, you'll see that many entries. But I think if you would see in the second case, even though there are many number of columns, you will only see these 4 or 5 entries in the hash, right? So I will do a quick demo, and after that, I think we can go on to the questions, right? So we have set it up as a Docker. Is this big enough or? So I have like 3 Docker images running here. One is for a standard Oracle, enterprise Oracle server, and then we have a Redis instance running, and then in a typical demo, usually like I show more than one Redis, but I wasn't sure of the internet connection, so I kept a local Redis instance here. And then I think there is the Golden Gate adapter that is running. So the way we have done it is we map our local folder, one of the local folders for libraries. So just the typical Oracle related libraries or whatever the vendor is, I think those libraries will be present in the Docker image for the connector itself. Right, so what I will do is I'll just get onto this one and then, right. So if you are doing Golden Gate, you actually like have this command line which you can execute all the Golden Gate commands. So if you see here, like there are 3, there is a manager which actually manages all the processes, and then I think you have exthr, that is the extract process that I was mentioning earlier about. So this is the extract process, and then the user exit is the one that is going to work off the trail files that have been transferred. So the user exit takes those trail files and then writes it into Redis. Right. So in addition to that, I think every vendor product is different. You will be able to roll back the changes. You can go back and replay them and all that stuff. So let's suppose, for whatever reason, you thought like I've replicated the changes to Redis, something happened, and you want to go back and redo it again from a given time. So you can always go back and start it again from that time, and all the changes will be replicated again. So those kind of like different vendors provide different support for that. Golden Gate has like good amount of support for like you going back in time and all those things. So let me go ahead and start the Okay, so now at this point we have all these 3 things running. Let me go to my Redis and make sure. Right, so I don't have any interest in, just for demonstration purpose, I'm going to use this tool dbeaver, which most of you guys be familiar with. It just makes it easier to show the entries over here, right? So in this case, I'm using this configuration right now. Right, so this is the configuration that is being used. So as I was showing, I'll show demo 2 different ones. The first one is a pass-through, which means that I think we are not all the columns from the source will go to all the columns from will get to the target. So what I will do is I'll just copy one of the rows. Oh, before that, let me show you the structure of this one a little bit. Okay. So if you see here, right, these are the trail files that are being generated. When I make any change on the source, these trail files get generated and they get shipped over to this one. So from the Docker image, whatever the changes that are happening there, the Golden Gate process like creates those from the redo logs. It reads that, ships the files over here, and this is the file our connector is going to read. And then you have like typical setup files like what the properties are for this one, and you can set your class path and those kind of things. We have put all of our libraries over here, and this is like where the config that is present. So tomorrow if I want to add a new one, new table and stuff, as long as the trail files are present, I would just go ahead and add the entry to my XML file, right? The XML config is one that determines that. So let me go ahead and make sure I don't have an employee ID 400, okay. So what I'm going to do is I'll just copy this row, right? And create I'll change the ID to 400, change the name and some of the details it might. Let me make this guy developer. Okay, right, so let's commit this one. So this row got committed. So now we don't have, if I go and execute db size again, we see one entry in this one. So let me go back and show you guys what it looks like over here. Right. So these like columns, obviously like we're not replicating in null columns and stuff, any columns that have null values, but I think if you see the name of the the name of the key is pretty much what is there in the column names in the Oracle database, right, on the table. So what I'll do is I'll go ahead and update the salary to like 10,000. And then when we commit it, let's see what this one looks like. So you can see the change here from that 9,000 to the 10,000 change that we made, right? So another feature that I want to show here is like if I go ahead and update, I was talking about that feature of synthetic keys. If I change the key, what would happen? We had set that property as like delete on key update. So let's suppose if I make it 401, the behavior that is expected in our case would be like delete the entry 400 because 400 doesn't exist in the database anymore. So we want to delete 400 and create like a key with 401. So as you see here, the 400 one went off, and then you see this one here, right? So that is like some of the features that we have implemented in there. So let me go back now and change this configuration to instead of the pass-through, I'll comment this out, and instead of pass-through, we'll make it like just like map the columns that we want, or like change the column names. So for this, whenever we add a new configuration, what we do on our side is usually we just like restart the user exit. Okay, right. So what I will do is let me delete this guy off. Okay, I think there is probably some issue there. Let me actually create this one again. Okay. Let me create an ID with 500. Hopefully 500 is not there here. So if I go back here and see what is the size of this one now, 2 entries in there. So if you see here, like now the same table, but I think what we did was we told, hey, we want the key names to be different. So in this case, what we have is all those changes basically are like taken from here. We are saying that the source is this, do the target to this one. Similarly, like we also have features like you can provide constant values. So if I want like a column that doesn't exist in the source, but I want to add a constant value to the target, we could do that as well. and do some lightweight transformation like concatenations and concatenation of 2 different columns and things of that nature, right? So that's pretty much, I think, what I had for the demo of this particular one. So similarly, like, we have done implementations for, like, we use the same configuration, but even though the vendor product could change, this configuration would drive for MySQL and MongoDB and other things as well. So that way, like, from the development perspective, we are not like spending cycles on learning like newer products, but I think we do more concentrate on the solution and sourcing the data and of that nature. So I think with that, if you have any questions, I think we could